Hey guys, this is Shelby with the Rogers Public Library. So last week we talked about microorganisms, and this week I want to talk about how microorganisms specifically um, make us sick and like cause diseases and stuff, right? And it is important to note that not all microorganisms are harmful, right? There are a lot of helpful microorganisms like the ones that live in our guts and that help us digest food. And there's other ones that are usually harmless, but that can be harmful under certain situations that are opportunistic and that can make you sick if you have a weakened immune system. And then there's the ones that are just harmful in general, right? And we usually give these a special name. We call them microbes or pathogens or germs, right? And right, diseases that first there's something called the germ theory of disease, right? And this basically says that for every disease, there's a specific germ that causes it, right? So if you're talking about, like, say, the plague, which is something that happened historically, like in the 14th century, that's specifically caused by a germ called Yersinia pestis, a bacterium. Right, and the diseases that are caused by germs are called infectious diseases, right? Because there's foreign organisms coming in our body and infecting us. And but not all, like, we get infected by infectious diseases, right? But they're not equally as transmissible, right? So there are some diseases that you can get just by being around people that have it, right? That they transmit from person to person, like the common cold or the flu. And then there's others that are a little, it's harder to get them, right? So like malaria. If you're in the same room as someone who has malaria, you can't get it just by being around them. It has to be transmitted through mosquitoes that have the disease. And there's a lot of diseases like that aren't contagious in the same way like something like the flu is. And one of these diseases that isn't really transmissible from person to person in the same way for the most part is food poisoning, right? And food poisoning is actually kind of a blanket term for a bunch of different diseases that are caused by different organisms, right? Like salmonella or E. coli. But it's, when there's germs that are growing on food and you eat them and the germs infect your body. And our experiment for this week, right, is we're growing germs on food. So there's a bit of a warning here, is that the germs that you grow in this experiment, you don't have a lot of control. You won't know what germs you're going to be growing until they've grown. And because of that, you want to be very careful and make sure that you're growing the germs in sealed containers so that you're not breathing any harmful materials and that can potentially hurt you or make you sick. And because of that, even though this is an easy experiment, it's something that you need to get an adult to help you with, just for safety. But the first step is you're going to take 2 pieces of bread, and one of them is just a control, right? So this is just a normal piece of bread, right? So that we know what a normal piece of bread will look like in a bag. And then this one is a gross piece of bread. So I got a paper towel wet, and I put it in a Ziploc bag, and I put the piece of bread in, right? And so that's, so now we have a very moist environment with a lot of different nutrients for lots of different things to grow. And in fact, we didn't have just one germ, but we have 3 on this piece of bread, right? So on the front, I know what 2 of them are. The third one, I'm not sure. On the front, we have this white-green mold. This is a penicillium mold, a bread mold. And then we have some different ones that grew on the paper towel on the back, right? This pink stuff is Serratium marcescens, right? It's actually a bacteria. And then we have this black mold that I have not been able to identify. I have some ideas, but I'm not 100% confident, right? So 2 fungi and 1 bacterium, right? So it's pretty cool just to see what different stuff that you grow, and you will grow something because there's just so many microorganisms floating around in the air that when you do this, there's going to be something on them, if not these exact ones that I've grown here, right? But when you're done with the experiment and you you've looked at this either with a microscope or a magnifying glass or something to your satisfaction, you're just going to want to take the whole bag and don't open it up, just throw it away, right? So that way you're not going to have to worry about breathing in any of the stuff that's inside. But the way, all right, so there's different ways that germs make us sick, right? And so there's some germs like mold. They make us sick because they produce toxic chemicals, right? So most molds produce mycotoxins that just harm our bodies directly, right? But then there's other germs that will make us sick because they use up the nutrients that our bodies need, and so they can't function properly, and bad stuff like cell death happens, right? But not all the icky feelings that we get when we're sick are actually caused by the germs themselves. They're caused by our body's response to the germs. So this is called an immune response. But basically, you have your body has a line of defense called an immune system. And your immune system looks for things called antigens, right? And antigens are molecules that are a sign that there's a foreign body inside of you, right? So they're not germs per se, but they're like proteins or other things that are on the outside of germs, cell walls, or coating in the case of a virus. And when your body detects these antigens, it sends out the troops, white blood cells, that try to destroy these the germs and produce antibodies to accomplish that. And some of the things they do is, right, they'll heat up tissue, and so you get fever or you might get an inflammation. And that's part of your body's immune response. It's part of what your body does to try to make you healthy again and to fight off germs. And sometimes this works really well, and other times it doesn't, and you have to go to the doctor, and they might tell you to eat some chicken soup, or they might prescribe you medicine. And there's a lot of different medicines that are available now that target specific types of germs, right? So there's antibodies or antibiotics that target bacterial infections. There's antivirals that target viral infections, like influenza, for example. Right? And yeah, so there's that. But the other cool thing about our immune system is that it has like a type of memory, right? So the first time that you're exposed to a germ, your body doesn't know what to do. It doesn't know what antibodies to produce to fight off infections. But once it's figured that out, it remembers germs. So the next time that you're exposed to them, your body does a better job of fighting them off, right? And because of this, there's some diseases that you can only get once. Like, for example, if you've had chickenpox in the past, you can't get chickenpox again because your body knows what the virus looks like and knows how to stop it from making you sick again. But right, and so this is immune memory. It's called immunity, right? But you don't actually have to get sick at all to get immunity, right? There's actually things that you can do to become immune without, exposing yourself to chickenpox or measles or anything. And we call these vaccines, right? And there's two types. There's attenuated vaccines that have weakened germs in them, and there's inactive vaccines that have dead germs in them, right? So you're being exposed to, but in both cases, you're being exposed to microorganisms that no longer are capable of hurting you, but that still trigger your body to produce antibodies, so that if you get exposed to those germs in the future, you won't get sick, or you'll get less sick. But vaccines actually have a really long history. So a very long time ago, but between 500 and 1,000 years ago in China, there wasn't vaccination, but there's something called variolation, right? Yeah, this comes from the scientific name for a disease called smallpox. But basically, doctors would take a really long tube, and they take some scabs from people who had smallpox and dry them up and crush them, and then they blow them in your nose with the tube. Right, so it's kind of weird, but this actually worked relatively well. People who were variolated like this, they would get a little sick, but then they wouldn't catch smallpox and get really sick later on. for the most part. It wasn't 100% effective. And actually, some people who were variolated in this way would go on to die, like 1 to 2% of people. But it turns out that there's another way that you can get immunity to smallpox without being variolated, and that's from cowpox, right? So cowpox is a virus that's related to smallpox, and people, specifically a doctor in the 18th century named Edward Jenner, realized that cow milkmaids, people who milk cows, would get exposed to cowpox, and they would never get smallpox, right? You would get, they're so similar that if you had the one, you would have immunity to the other one later on. So he took like the pus from the pox, right, and he'd inject it in people's arms. And when that happened, they wouldn't get smallpox. But the name for this technique comes from the Latin word for cow, which is vacca, right? So they're vaccinations. And because of this vaccine and later smallpox vaccines, there's like the disease has been completely eliminated, right? So it doesn't exist in the world. You can't get smallpox today. No one can. And the last time that anybody got smallpox was like in 1979. So that's just really cool to think about. But to end on a bit of a lighter note, I want to show you a craft that I did. And that's just, I made some germs. So you can take this to different levels. If you want to be, you can't just make a kind of a weird generic germ like this, right? This is supposed to be an amoeba. And I put eyeballs on it and did a little smiley face, so it's a cute amoeba. Or you can try to make specific microorganisms, right? So you can, some ones that I think that a lot of viruses look cool if you look at like microscopic pictures of them. So there's one called rabies lyssavirus, which is what causes rabies. But it's got like a really weird shape. It's almost shaped like a bullet with little tiny hairs on the outside, and then on the inside of this capsule is a strand of DNA, right? So this is rabies lyssavirus. Another really cool shaped virus, or a class of viruses, are called bacteriophages, right? Not all bacteriophages look like this, but a lot of them do, right? They have like these really weird like spider legs. And then they have a capsule that's shaped almost like a gem. And inside this capsule, there's DNA kind of like in the rabies lyssavirus, right? And as for actually making these, I just did it with construction paper and scissors and a marker and glue. But you can get a lot fancier than I've gotten, a lot more detailed if you want to. But that's what I had for you guys this week. I hope you had fun, you learned something, and I'll see you next time.